about monitoring reef island size and like how we did that process here. So most of the year of project, we focus on data collection methods, and so that's the core of the Surfside Science project. It's like, how do we collect that data that's currently missing in Aruba, and that's key to understanding our current situation and our future resilience, looking at predicted impacts of climate change, right? But especially for you guys, we actually went and we downloaded some of the data that we've been collected and did a very short analysis of the changes that we could see in the past 3 years on the Reef Islands. We had done an initial set of research earlier this year for the Dutch Caribbean Research Week to look at longer term changes between the year 2000 and 2022, and we're going to do a little bit of a comparison on this. We want to focus on the Reef Islands because, well, yeah, the next. So yeah, we, like Steve said, we looked at a lot of different things, so all of these posters are telling you about different elements that we looked at for this year of research, and mostly just data collection and validation of the methods to like confidently suggest the use of this data. We actually started on this trajectory in 2019 with support from UNESCO, so we had some like prototypes, so we were already at that phase where we could now replicate them and then start improving them and then testing them. It was, very chaotic. We might have been over ambitious, so we did test 14 different parameters in total. So it was a lot. Some of them are combined, like for air quality, there's 3 different parameters of air quality, but it's one sensor, so that was a bit easier. But yeah, it did, in the end, it was a lot. Doing it in a year, ordering sensors, going through the European Union bureaucracy of how to change your budget. It was it was not easy, but we do now have a functional database where you can download the data, and we're hoping to improve and expand this process. But yeah, today we want to talk to you specifically about Reef Islands. So this is the first map ever drawn of Aruba by Europeans. So this map, drawn in 1773, is a very poor map of Aruba, the main island. It's a very good map of the Reef Islands. So the Reef Islands at the bottom, they're drawn in a lot of detail. And all those dots you see, all the gray area, are mangroves. So this is because most of Aruba's leeward coast was protected by a long kind of barrier reef, and elongated islands connected to each other. And that made it very hard to come to Aruba, right? Because you kind of got stuck on the reef. So this island protected us in many ways. And actually, once Aruba started to get more actively colonized, they had to cut the reef open. So our process of colonization has been from the start also a process of destroying our reef. And it continues to this day, right? And Surfside is basically the main beach in downtown, which is where I'm from, it's where Celin's from, where the university is located. It's the first kind of urbanized area, or more like where people went to live in the post-colonial era, not in the pre-colonial era. And this area is where a lot of wastewater went directly into the ocean, and it's where the land was reclaimed, right? So they filled a lot of the wetlands. It's very strongly developed. That area used to be called Padenbij because it was one of the main areas where boats used to come in, and they used to throw the horses off board to swim to the coast. So it's a very important historical area. It's also where the first hotel was ever built. It's where our airport is. And so this beach, that when you go, it's full of seagrass. Like, everyone was asking us, why won't you study Surfside? Right? We have so many beautiful beaches. We have so many beaches with more going on. Why look at Surfside? And I think Surfside is kind of like at our core, right? It's where we want to start. It's what we want to understand. And it somehow still has coral, has fields of seagrass, has reef islands that still exist even though they're disappearing rapidly. And it still has wastewater coming in, cruise ships passing by, and it is one of the only beaches in Aruba where you can go and hang out under a bunch of mangrove trees, fufwoti trees, which are like the trees that Aruba uses to promote itself with. And so it's very popular also among families. Like if you go on a weekend, you will always find someone having a birthday party at Surfside. And so like seems that it's a very strong memory beach for a lot of Arubans. It's a place that is more local in a lot of ways. Even though there are hotels there and restaurants, a lot of people really live, part of their life at Surfside. And every day you go, you also see people fishing. So it is a beach that is very active in a lot of ways. The regatta takes place there. We have like a history of miniature boats competitions that takes place there. So our governor's house is there. So it is really an under kind of appreciated beach. And so we wanted to bring some attention to it. And if we could measure there, right, where we have everything going on, extreme pollution, urbanization, then I think we could also use it in other places. So that's another benefit of looking at Surfside. The reef is super valuable for the island. You'll know right now with climate change that a lot of places are looking at building seawalls. We have seen a lot of seawalls get erected along Aruba's beaches as well. A lot of money goes into that. And the reef islands offer us a natural seawall. It protects our coast. It provides us with food. It protects us from sea level rise as well as from storm events. So we wanted to take some time and see like what is happening with that, because a lot of people's experience is that it's disappearing. So next. Tony's going to talk to you a little bit about how we did that.
Yeah, so the methods. Christie mentioned in May, last year, but leading up to a presentation in May, we did a more manual technique. So we digitized the Reef Islands based on Google Earth images, which are very high resolution satellite pictures. You can see each individual island and then you can trace them, and then you can take measurements based on that shape. So we did that for the year 2000, as far back as we could find high resolution imagery, and then we did it for the most modern picture to see the widest time scale, and that was 2022 or 2023 for some of them. So we did that, and then we compared the sizes between the 2 years, and the total area reduced by 10%, just over a period of 20 years, and the number of islands reduced by 20%. So these are pretty stark results that we saw. This is the summary of the results. So the size of the circles indicates the absolute change in the size of the island. So there's one dot for each island, and the color of it indicates the relative change. So one that's red disappeared completely. One that's a big circle but like light red, reduced in size, but it's a big island, so it's not as significant. Like it's not visually maybe disappearing from the perspective of someone just looking at the island, but we can measure the change in square meters. We noticed there's a couple areas where there's more, but this one we had to do manually for these two points in time, and it's not something that's going to continue by itself. You need someone to keep looking at pictures, keep tracing them to continue monitoring. So we wanted to figure out another option. So this is a video of one of the islands that changed a lot. So I hope it plays. The right next to where it says St. Nicholas Bay. Keep an eye on that island, and I'll just play a short time lapse of the imagery we used for this process. yeah, so you can see pretty significant changes. This one reduced by like more than 50% in size. But these things can also be dynamic, so we want to keep monitoring them to see like if it's just islands disappearing and then we'll have no islands, or if it's like seasonal changes. But so we needed to figure out another way to do it, to keep doing this. So we use Google Earth Engine, which is like a satellite imagery analysis, satellite imagery derived data analysis platform. So they have ways to analyze open access data using code. So it's, if you want to start, you can grab someone else's code and just press play. You can change the location or the date and look at a different place at a different time. So we use Sentinel-2 data because these are some satellites from the European Space Agency that take pictures of the whole planet every 5 days, and they're at 10-meter resolution, so each pixel is about the size of this room, which is pretty good for the frequency with which they take these pictures.
That's you. I thought you were not talking.
Should I join?
Click start button on the right hand side.
That's it.
There you go. Weird. And turn on the video and you'll be good.
Okay,
Here you are.
we're back. Oh, do I need to share the screen? This, no, this one. Excuse me. So the combination of this imagery and this platform is what we worked with to try to develop a way to monitor the Reef Islands like on a more frequent basis and to automate it. So to take the code and get like a software platform that just runs this code every so often and creates a new map. Yeah, so this is the image of Aruba from this data. So this is the 10 meter pixel resolution. So you can see the islands, you can see a lot of detail on the island, even though it's like pretty big pixels. And this is the Google Earth Engine platform, so the code is there in the middle. And you just click run, and then it makes the map on the bottom. So the yellow has been identified as Reef Islands. The blue is the imagery that was analyzed. And then the outline of the blue is where we outlined the Reef Islands are going to be within this. So we define like an area to analyze, so it doesn't look at everywhere in the world or all of Aruba. And then we want to see changes within that area. So this also outputs downloadable files and a CSV of the areas for each island. And it prints it out over on the right, so you can also just use it manually and just make notes as you go. Yeah, this just describes the step-by-step of that. So we ended up doing it once a month and masking out clouds, because those are like the biggest challenge for seeing the Earth from space. Yeah, we took a few pictures within a month span, and then from those we took all the pixels that didn't have clouds and then combined them into one picture. And then there's different reflectance in the light from water and land, so we used that to figure out which part's island, which part's not. So the output is the boundaries of each island. These are the files that you can download on our data portal. Check it out. And then it calculates the areas of each of these islands. It also shares the Sentinel-2 image that these were based on. Yeah. And this is what it looked like at our study site, Surfside. This is the pilot site for our project, what Christie was talking about. So the purple is the end of Renaissance Island. The airport is over here. The cruise ships come through here. This is a little island over here, and then there's a couple little islands over here that are changing a lot. Yeah, and then this is the beach. So for the analysis of this data, we grouped the islands by reef platforms so they have the same underwater structure, and then analyzed them together because each individual island has a lot of variation. So Christie will talk about what we've done.
Alright, so we don't have a lot of time, so I'm just gonna show you the collective change, not we have like a platform by platform review. But basically each of these lines is a reef platform. So when you look at it on a satellite image, you see, like in the previous picture, you can see the light blue, right? You can see the reef platform. So each of these, and this one you can see in the middle where it's been cut for the cruise ship, that's been cut open and dredged, right? That's why you see that deep blue line in the middle. That's not its natural shape, that is what we do to allow cruise ships to come in this close to the island. Otherwise they would have to be on the outside of the reef and then take a small boat in, like some islands do that. But yes, so these are different platforms. Most of them are separated because they were cut. So a lot of them have historically been connected. And interestingly, they're also connected to our main dam. So a lot of our mangrove forests are connected by reef platform to the reef islands. So that is kind of cool. So we combined them, which is different from what we did before. Before you could see all the dots. Each one was an individual island. So in the year 2000, we had 45 individual islands. So by combining them, we could see if a lot of times when one of the main islands is shrinking, it fractures. So it breaks into smaller islands. And that was hard to monitor when we were doing individual islands because then you suddenly have a new island that you have to add. And then the main island will shrink, but then the new island will grow. So then you want to see like, what is that interaction? So we figured that by looking at reef platforms, it would be a more consistent unit. Does that make sense? So yeah, we are looking at Harbor Island, which is the one at Surfside. We're looking at Renaissance Reef, which is the one, that is the biggest one really. It's a private island, but it is and then we looked at Bacadera, which is more the industrial side. Savaneta, which is one of our main diving sites, which is near a mangrove forest. Near the refinery, this is very interesting. So we have two reef bodies around the refinery in San Nicolas, one near its own harbor and one on the other side at Rogers Beach. So yes, this is each one. So we did clean out, we took out some dates when it was particularly cloudy. So when we first downloaded the data, you would have some dates where it went to like, whoop, 0. And so of course, then we went back and loaded the data that we downloaded to double check the dates. And we would see, there are some days where there's just chunks of islands missing because of cloudy days. Aruba is very deserty, so we don't have that many days where you couldn't get a composite image over an entire month. But we took some dates out. And this is pretty much what it looked like. So what is interesting is that this is consistent with what we read in the literature, that islands are dynamic, right? So you can measure something 1 month and then another month and you'll see a big difference. But they do kind of trend in one way or another. What's interesting also is that over this shorter period of time, which this has been a few years where we haven't had many storm events or hurricanes, a lot of the islands did show growth, which is also consistent with what we read in the literature because they are living islands, which is kind of cool because they are reef islands. So if the reef is healthy, the island can actually grow and it can grow back after a storm event. And it can actually also, according to a lot of research, keep up to even sea level rise because it can change its growth from plateaus to vertical units. So that's really exciting. So if we take care of our reef islands, they can provide us for protection for a long term, and we can see that the islands are able to grow. One of the very interesting elements is that actually if you see over here, the refinery, I can't point it. So the refinery reef, which is the one right off of the refinery, which of course has been, I'll just jump to it. This is just a shocking image of the reef at the harbor in 1940 versus like what it looks like now. It's basically completely underwater for most of the period. We just jump to the refinery reef. This is just, it's been dredged all around, right? Because this is where all the big oil ships went. And this island is showing some of the most growth. right? Because it's been basically abandoned for the past 10 years. And so that capacity to bounce back, I think, is also something that we should kind of find some solace in. And also, you can see here, right? You can see how the reef platform has been cut, right? Made dredged in between the smaller reef and the bigger reef. So there's also a lot of, I think, need to allow some of that area to recuperate, especially if we're not using it anymore for industrial uses. And but yeah, so these islands are shrinking really fast. That's the other end of the island, so we see the biggest loss happening at the two ends of the reef platform. There's a whole section from Punta Bravo, which if you look at a map of Aruba, you'll see like a point where the island turns up. So basically that whole area also has reef, not the area that goes up. So if we look at the original image, yeah, so basically the whole flat side, so from there all the way to San Nicolas, all had reef. And so a big section going to the harbor has already disappeared. You can still see the reef platform, but there is still a very large section, and it's about 70% of our coast on the east side. And so I think basically what I want to leave you with is that we should be monitoring it, and that is key to finding out what are the reasons why we're seeing such a huge loss and how we can protect it and allow it to grow, and provide us with all the benefits that we get from it. So just to show you one more picture, this one I find it kind of a mixed. This one at the Renaissance Reef, almost the entire platform is populated by the Reef Island, right? So this one is our best example of like a thriving reef, and even this one is losing huge sections at both outends. So on this outend, very recently, it's been being developed by, I don't know. And in the main area that's used for the tourism, you can see how they've lost huge chunks by cutting out the mangroves and making a beach. And then they had to build a seawall, right, to keep that beach, because a few years ago, that island literally broke in two in the section where they tried to build a beach, right? So they've been reconstructing it now. But this kind of shows us some of the changes that we're seeing. What's been interesting is to see over this shorter period of time, the opportunity for recuperation and the dynamism. And so from here we want to go further and see, which islands are more stable, what could that be based on. But yeah, this is an initial review, so I hope you found it interesting. And yeah, I think we're open for questions.
Just linking the keynote to what was just being told, the reef islands in front of St. Nicholas, the refinery, and Natasha telling us about the special tern populations. These islands are actually breeding grounds for the Cayenne terns, and also the north coast where tourists go with UTVs. If any of you rents a UTV and goes driving over there, you're not my friend anymore. So these are actually the breeding grounds of these unique populations, just to know that.
Yeah, and even at Surfside, we've seen reef sharks,
Yep.
we've seen a lot of turtles, there's even like pillar coral, so,
Biggest barracuda I've ever seen in there.
Oh, cool.
Don't go fishing.
So we have time for 2 questions. Reflections. Hello.
Yeah, I'm very curious about what's next, future plans. You're funded by the European Union, which is great, but the funding stops at some point. It might have stopped already. And what are plans to continue this work?
So we are applying for more funding. So we're applying at different projects. We designed the project so that it could kind of continue to collect data after the funding was done. This is why a lot of the processes of automation took place. So the data automatically kind of like scraps or runs itself again every month to update the database. So we're hoping to also expand the number of people that are analyzing these changes beyond our team. So for the project, we weren't supposed to be doing the analysis, we're just providing data. And the sensor stations are also automated, they're solar powered, they just need 15-30 a month for data for their 3G system, and we're finding hosts. So we currently have 3 hosts, so Pure Diving, Stichting Rancho, and Scubba Bubbles to host some of these sensors in the areas where they themselves also would like to use that data, and in that way we want to expand the areas and the people involved in that process.
Well, to answer your question first, I think it's super interesting. Really nice data set that you've collected. Like when you aggregated the data to the platforms, you saw like towards the end of the time series like really strong correlation between the platforms in terms of the dynamic. And I wonder, do you like if you look at the islands within the platforms, do you see similar strong correlation between the islands? Are the dynamics kind of synchronizing over time? Or do you see variation within?
It varies between them. So a lot of times you'll have like one island growing and several islands shrinking. And so what we see when we see the images also is that sometimes one island feeds another island, right? So one island is disappearing and then it kind of, some of the sediments then will like get stuck on a different island. So that's strongly happening between Renaissance, and there are like the 2 islands off of Renaissance. So if you see, if we go back here, those 2 islands there originally didn't even exist. So first the island just kind of shrank, and then another island kind of pops. So I think also for the harbor reef, there's an interaction between these 2 islands. So it's like they're very small, and a lot of the time they're completely invisible because they're just sandbanks. But yeah, especially the more sandy islands seem to also kind of feed back between each other. But the total seems to then still, when this is happening, need show that they're shrinking.
Kind of like, and have you been able to kind of look at how the, so on the one hand you have area, but then you also have kind of like the morphology or the patch shape, and whether kind of like the shape could also kind of indicate whether, given a certain area, that there might be like shapes that are more resilient to erosion versus others. Is that something that you have been able to do?
On our research that we did, when we did for each island, so for this one, we actually also calculated the roundness, so like how round each island was, because historically the islands on Aruba are elongated shapes, and so we saw that over the 20-year period, the islands had become rounder overall. Yeah. And so also when they fracture, the fractured elements tend to be rounder, which is kind of, because round is a more stable shape, but it actually, the elongated reef is the more stable reef, so it's kind of interesting, yeah.
We would like to thank you